Hey everyone, welcome back to the wonderful world of AP Chemistry videos. Thank you for tuning in. I normally don't like to pile on day after a test with a bunch of homework or anything, but I was planning our next lesson for Chapter 4, and I figured that if we could get through some of this early definition stuff, that when we get to class we could focus a little bit more on problem solving, which will be more beneficial to you in the long run. So if you can just bear with me here for just a quick video while we introduce some of the terms, I think it would be a big time saver later this week. All right, so the first thing I have up on the screen here, we have a glass of water and we have a spoon of salt that's going into the water, and this is exactly the type of thing we're going to be talking about. The name of this chapter is called Reactions in Aqueous Solution. Okay, so when we're talking about aqueous solution, the first thing we're talking about is aqueous. Aqueous means water. Okay, so we're talking about reactions that are occurring in water. Now, when we say solution, what that really means is that water is acting as a solvent and it is dissolving a solute. So in this case here, we have some salt that's getting dropped into the water. The salt and water will mix and they'll make a homogeneous mixture. And so the salt is the solute, and again, water is the solvent, and together they make up an aqueous solution. Okay, so just a solution that is made up in water. One of the things we're going to learn about here is the difference between dissolution and dissociation. Okay, so dissolution is anything that will then mix with whatever the solvent is and make a homogeneous mixture. That is different from dissociation. So dissociation is very specific in terms of making what they have on this slide here, called electrolytes, which you'll often see on maybe the side of a Gatorade bottle or something like that, where you see lithium plus on the side or sodium plus. And that's really what it is. It's things breaking into their ions whenever they get into solution. Okay, so there is a difference between dissolution and dissociation. So dissolving is becoming a homogeneous mixture with the solvent, and dissociation is actually breaking apart into the ions. So you can actually have things that dissolve that don't dissociate. So something like methanol or other weak electrolytes, they can mix with water, but they don't actually break apart into ions. And then you can actually have things that are not really soluble. So something like milk of magnesia, which is magnesium hydroxide, it is really not soluble at all, but the little bit that does dissolve completely breaks apart into its ions. So it fully dissociates even though it doesn't really dissolve. So there are two different concepts that can sometimes be confused. So try to keep those straight. So an electrolyte is something that is going to dissociate into its ions when it's dissolved in water. All right, so here's another good example of this. Hopefully you remember from your other chemistry classes that water, in order to conduct electricity, needs to have some type of ion in it. Okay, so you need something that is going to dissociate in order to conduct electricity. So on the left picture here, you have pure water. It does not conduct electricity. In the middle picture here, they're taking something like sugar. So sugar is not an ionic compound, but it does dissolve in water. So you can see that it still dissolves in water, but you do not get any electrical conductivity. And then finally, the picture on the right, they are adding salt to the water, and that's where you have something that's actually dissociating into its ions. So sodium chloride or salt is a good electrolyte. It breaks apart into its ions when it dissolves in water. Okay, so you then get that nice electrical current that's able to light up that light bulb. So the first big thing in terms of chemical reactions that we're going to learn about in aqueous solution are double replacement reactions, is how you may have heard them in honors chemistry. Some people call them metathesis reactions. But pretty much what we're doing is we're taking two ionic compounds, so something that has a cation and an anion. So again, remember the cations are positive. Cats have paws. So the cation is positive, and an anion. And you're going to mix it with another ionic compound with its cation and its anion, and they are going to flip-flop. Okay, so the cation from one is going to mix with the anion of the other. So in this case, silver and chloride are going to mix, and then the cation of the other is going to mix with the anion of the first one. So you end up making these two things, silver chloride and potassium nitrate. Really important when we talk about these reactions. In order for this reaction to occur, it needs to make one of three things. Okay. So the first thing it can possibly make is a precipitate. And that's exactly what's happening in this reaction. Precipitate. Okay. And in this case, silver chloride is our precipitate. So a precipitate is something that is a solid that crashes out of the solution. Okay. So silver chloride comes out as a solid, as you can see here by its indicator S. So it is a solid. So that is what drives this reaction to completion. If you don't make one of these three things, no reaction will occur. Okay, so we're going to learn some solubility rules that will help us predict whether, which product might be a precipitate. The second thing that can drive a reaction to completion is that it forms a gas. And so if a gas is formed, it evolves, and so that will then eventually push all of the reaction to completion. So if you form a gas, that would also work, and we're going to learn about a few of those. Oh, I don't know what happened there. Finally, the last thing that you could form is water. And another way you can think about this is called an acid-base reaction or a neutralization reaction. All right, so if you make a precipitate, if you make a gas, if you make water, all of those things would actually make a reaction occur. If not, all you're going to end up with is a whole bunch of ions floating around. So if these two things didn't form any of those, you'd have a bunch of silver ions, you'd have a bunch of nitrate ions, you'd have potassium ions, you'd have chloride ions. Okay, so all those things would just be floating around in the water and nothing would really be happening. So you have to form one of these three things in order for a reaction to occur. So hopefully you get this idea of what a metathesis reaction is exactly. So here's the little more specificity on each of those. Here's an example where you have two colorless liquids, each with different ions in their solutions. When you mix them together, this very nice lead iodide product forms. It makes this very nice yellow solid in the flask here. And so then it forms a precipitate. And we'll, like I said, we're going to learn some solubility rules to be able to predict which product would be the precipitate. So we'll do that next time. One of the other ones, like I said, is neutralization reactions. So here we have a strong acid in HCl mixing with a strong base in sodium hydroxide, and that's making a salt in water. So even though there's no solid forming here, we are making water, so a reaction does occur. Okay, so we are neutralizing the acid with the base, and don't worry about this stuff right now. We will talk about that next time. Okay, but just know that if you're mixing an acid, so the H plus with the base, here's OH minus, we're making water in the process. Okay, so we're going to learn more about acid-base reactions. And finally, number 3 is going to be gas-forming reactions. There's really two main things that are two gases you need to be on the lookout for to know that it's a gas-forming reaction. Okay, the first is when you do an exchange reaction where the product would normally be H2CO3. Okay, so in this case, when you take HCO3 as the anion and you mix it with the cation over here of hydrogen, you would think, okay, well, H2CO3 might be the product. Okay, what happens is this is a very unstable compound and it quickly decomposes into carbon dioxide and water. Okay, so this is just one exception. You have to watch out for it to know that that is going to form CO2 and water. Okay, H2CO3. The second one is hydrogen sulfide. And again, if you're doing a reaction with sulfur here, with the sulfide ion, that's S2 minus, and you're mixing it with an acid, H plus. When these two things undergo the double replacement reaction, you get H2S, and that's a very smelly, it smells like rotten eggs, hydrogen sulfide. Okay, so that is another gas-forming reaction that you should know about. All right, so that's really all I have queued up here. Please leave any comments you think about the video. Let me know if you have any questions, and when we get to class, Really all I want you to know is, one, what is a double replacement reaction, and two, when we do these double replacement reactions, knowing that it either needs to form a precipitate, water, or a gas in order to successfully go to completion. So if you got that much, I'm happy, and I will plan on seeing you guys next time. Have a great night.